Okay, good evening everybody. My name's Dave. I'm Vice Chairman for Appledore District Radio Club. Tonight we have a very good talk by our President about aerial design and design. Dave, I'm Vice Chairman for Appledore.
Okay, a very good evening everybody, and also welcome to any YouTube viewers that we might have this evening joining us for this talk. Before I get started, I just wanted to really try and explain a bit about the background as to how the talk arose. My QTH, fair to say that as far as antennas are concerned, unobtrusive is the key word. So as a result, my antenna is just a 20-metre end-fed, just 5 metres above the ground, which it sort of works. It will get me into Europe. But the thought of trying to work any further afield is really wishful thinking. So early this year, I started thinking, I wonder if it's possible to actually design a 20-metre antenna, which, is unobtrusive, but also will give me a chance of working some DX by having. And really, it was that which then led to the title of this talk, which is the design and I'll say hopefully the demonstration, if time permits and conditions permit, a demonstration of a compact 20-metre antenna. So where to start? Well, probably what we want to try and achieve, which is obviously resonance in the 20-metre band. I've chosen 14.2 megs, just something to aim for. SWR, less than 2 to 1, so we don't need to think about using an ATU. And compact height and size. So thinking about my QTH, I would say absolute tops 8 metres, but if I can get it down to nearer 5 metres, I'll be a happy bunny. And if I can do that and still get some sort of low angle radiation, then, you know, job done, so to speak. First job is to decide on what antenna to use, and I discounted quite a few on the grounds that either they've got to be too high to keep the radiation angle low, or they need a really good earth plane. I didn't want to bother with that. And at the end of the day, I suppose it was just, well, subconscious really, but inevitably I came back to my favourite antenna, which of course is the good old loop. And it comes in various shapes. These are the two most common shapes, the quad and the delta. But it doesn't matter what shape the loop is, there's one fundamental fact for any loop, and that is that its circumference must be a whole wavelength or a multiple thereof, which at HF effectively means one whole wavelength. So the quad has got roughly 5 metre sides and the delta about 7 metre sides. You'll see that I've actually made the height of the antenna about 1 metre above ground. Bit of a compromise, but an attempt to try and keep the overall height to a minimum. So, which to choose? The quad or the delta? Well, as you can see, the delta is what I've decided, because although the quad's lower, the delta is so much easier to support just with a single vertical pole. The only thing is, I've decided that the pole needs to be non-conducting. Because had it been, say, aluminium, then currents would be induced in the aluminium pole, and that really makes it an integral part of the antenna and the design. But because, to keep things simple, I've said, right, let's keep to a non-conducting pole. In fact, I've rightly or wrongly just used a glass fibre thing outside. I don't need to worry about the pole in the design. Okay, we know the antenna. What about the software? There's just few of the ones that's freely available. But at the end of the day, it came down to a choice between the MMANA GAL and the EZ NEC. I mean, the MMANA is a delightful program with a nice user-friendly interface, and it's got a unique facility in that there's an optimization routine built in. But on the downside, it can't cope with mixed materials. So you couldn't have a copper wire with an aluminium pole. And also, it can't cope or take into effect the wire insulation, which, as you may know, does change the velocity factor within the wire. Easy NEC, on the other hand, I personally think is not quite so user-friendly, but nonetheless well worth the effort getting to know, because it ticks all the boxes. Yeah, you can have mixed materials. Yeah, it takes into account the wire insulation. You can even include transmission lines in your design, and you can include transformers like balance. And I'd almost made my mind up, and then I came across this piece of information on the web. Now, some of you may already know that, but this was complete news to me, that the author of Easy NEC some years ago he retired. And as of the start of 2022, certainly one professional version, the Pro/2 Plus, which previously used to cost, well, hundreds of dollars, is now actually a free download. And I can vouch for that because I downloaded it this April. I don't know how long it's going to be like that, but you know, I grabbed it while it was there. Obviously, it's now unsupported. And really that clinched it. Decided on that's what I was going to use for tonight's talk. But it doesn't matter which program you use, they're all going to require you to put in details of the antennas, of the actual wires, shall we say, that make up the design of your antenna. And the software makes two demands. One, that the wires all have to be straight, and secondly, that you have to define the beginning and end point of each of those straight wires. And they do that with a system called XYZ coordinates, which usually strikes fear into the hearts of many, but as I'm hoping to show, it's not that difficult. So here we are, our starting point. A simple delta, all three sides identical, same length, and I've rounded them off to just 7 meters. The apex is at the top, as I said, so it's easy to support, and the bottom wire is horizontal and 1 meter above ground. So, what about these XYZ coordinates? Well, let's do it back to front. Start with Z. Z is really the easiest because it's just the height of the point above ground. Y, I'd like to think of as also being quite easy, because if you think of it as the distance that the point is either behind the screen or in front of the screen, but if we make the antenna part of the screen, then Y is 0. So let's take care of that. And finally, X is just a horizontal distance. So let's apply that to wire 1, the bottom wire. Well, we know it's horizontal. We know it's 1 meter above ground. So it's fairly simple to say that both ends, Z is going to be 1. We know that Y is 0 also everywhere, so that's taken care of. And if we let the left-hand end 1 have an X of 0, and because the wire is horizontal and 7 meters long, it follows that t'other end, N2, X is going to be 7. So that's taken care of. What about Y2? Well, there's one main requirement of Y2, and that is that it must be electrically connected to Y1. And for that to happen, the software again makes two demands. Number one, you can only connect wires at their ends. And secondly, if both ends have identical XYZ coordinates. So immediately we know that end 1 of Y2 excuse me, is the 7, 0, 1. Done. What about the other end at the top, end 2? Well, first of all, X. I think visibly we can see that the X is really halfway between the beginning and end X values of Y1, which goes from 0 to 7, so at the top, X is going to be simply 3.5. We know Y is 0 everywhere. What about Z? Well, this is the only little bit of tricky bit. It's obviously 1 metre plus the 6.1 metres. Where the devil is the 6.1 metres, you might be saying? Well, that comes from a little bit of trigonometry in the old sine rule, but forget all that. It boils down simply to being the length of wire 3, 7 metres, and you multiply it by a magic number 0.866, and that gives you the 6.1. A few clicks on your calculator and it's done. And of course 7.1 is also the overall height of the antenna. Wire 3, well, we know that simply needs to be connected electrically to end 2 of wire 2 and end 1 of wire 1. So it simply takes those coordinates. So job done. So now we've got all the details of the wires ready to put into Easy NEC. So what I'm going to do now is sit down, if you apologise for that, and we'll have a go and see if we can then load up Easy NEC and see what we can achieve. Here's the opening screen of Easy NEC. They call it the sort of control centre because everything starts from here. I hope you can sort of roughly see it, but before we actually put the wire details in, there's a few little basics that are worth doing. You only need to do it once and then bingo, it's finished. The first is if you left click on that shaded area at the top, you can use 30 characters to give your design a name, a title, which is quite useful. And then if you click on the antenna notes, then that enables you to give as long a description as you want of your antenna, which to be honest is quite useful to refer to at some time in the future if you've forgotten how the devil you did it. Also, we need to know the frequency. So if you click on frequency and just enter, as we know, 14.2 megs, the program now knows what we're trying to achieve. And finally, it needs to know what on earth is the ground that's underneath the antenna. So we click on ground type and it gives you 3 options. Well, it certainly ain't in free space, nor, unfortunately, is it over perfect ideal ground, but it's real ground, and I've chosen the high accuracy type. But it needs to know just what is this real ground. I mean, that isn't enough. So just then click on the wired on the ground description and this very unhelpful window opens. And you look at that, and if you're anything like me, you scratch your head and say, now what? But panic not, just go to the first entry and right click on it and you can choose what sort of ground you think is at your QTH. So when you've taken care of that, the only thing left really at this stage, quite usefully, is because we're only using copper wire, where it says wire loss, if you click on there and just choose copper, then that's taken care of. And you'll see underneath that the units, I've chosen meters, but you can decide what on earth you like. So now we've got all this basic information, we can forget about that for the rest of the evening and go into clicking on wires. And this window opens, which sort of looks like a little mini spreadsheet. The first thing I'll say is that it's important that these 2 boxes are ticked, because if they aren't, all these end columns won't appear. And you certainly want the wire insulation columns there. So I keep those ticked. But basically, it's just 3 rows, and each row represents a wire. And for each wire, you've got to obviously put in X, Y, Z, N1 and N2. And whether you can remember, but first row is wire 1. And if you remember, it started at 001 and it went to 701. And then, of course, wire 2 has got to start there to be electrically connected at 701 and so on. We then come to the diameter of the conducting wire. Well, I have to say many thanks to Mike G4CHD for his loan of his very precious micrometer, with which I was able to sort of guesstimate that it was about 0.6 of a millimetre and that the wire insulation was about 0.33. It then asks for something called segments. Now, this is a number which you are asking the program to theoretically divide up each wire up into this number of segments, so it makes the calculating much easier. And suffice to say, the more segments, the better. But unfortunately, the longer it takes. So it's a compromise. I would say the minimum, because our wire is what, about 7 meters long, the minimum is probably about 20 segments. And being a professional version, you could theoretically go up to 1,000 or more segments. But if you try more than, say, a couple of 100, you'll find it'll keep coming up with error messages saying your segment is too small. So in essence, some number between 20 and 200, and rightly or wrongly, I just picked 100. It'd have been probably better with hindsight to have chosen 50. It would have been a bit quicker. But the one thing I will say is that they recommend that all 3 wires should have the same number of segments. And finally, we already know that the wire is copper. We've done that under wire loss. Wire insulation. Well, we know how thick it is, but it then asks really for its dielectric constant, which again, if like me, your eyes go glazed at the very thought of it. Again, panic not, simply right click at the entry, if I can right click, and up comes a number of choices. As you see, PVC was what mine was. And now we've got the wire details fully in, and the only thing left is to decide where you're going to feed it. Well, it struck me sensible and practical to feed it at the bottom on wire 1 somewhere. And I chose the middle to start with, but I was very disappointed with the results because most of the radiation was going straight upwards. But I still wanted wire 1, so I decided to put it at the start of wire 1, which in essence, think about it, is where wire 1 and wire 3 join each other right in the corner. And you do that by clicking on sources. And you'll see that we've already filled it in. Wire 1, 0% from the end, which is the beginning of it. And what's important is the type. And it's SV, which stands for split voltage. And all I'll say is that it is recommended that if you are feeding the antenna at the junction of 2 wires, you use a split voltage source. If on the other hand you were going to feed it halfway along wire 1, you just use an ordinary V for voltage source. Simple as that. So now we've got everything in. There's one last thing that's quite useful to do at this stage, and is to click on View Antenna, and you get this window come up. You can't really see it, but there is a very tiny red circle in the bottom left showing you exactly where the source is. And also what's quite useful is if you hover the pointer over any wire, if I can only hold my mouse still enough, a window will come up telling you how long that wire is and what the coordinates are of the nearest endpoint, which is quite useful. So looking at that, it looks right. I've not made any massive boo-boos. Let's go in and start actually designing. So the first thing obviously is to do an SWR plot. Click on SWR and run, and it chunters away. Now I've chosen to run from say 13.5 to 15.5 megs in 0.1 meg steps. And here we've got a resonance at this point here, and at the bottom it tells us at 14.4 megs, and the SWR is about 3.15. Well, immediately, if this was the antenna that you were going to use and you're happy with it being 7.1 meters high, then obviously being resonant 14.4 needs to be made just a little bit longer, 1 or 2%, to bring it down to 14.2. And also 3 to 1, I wouldn't like to feed it directly. Either you need an A to U, or if you look down here, the Z is about 150 odd ohms. So why not just use a 4 to 1 balun at the feed point, and that would take care of most of it. But there's no point worrying much about this if the actual radiation pattern is hopeless. To do that, you click on FF, which is far field plot. But again, there's a couple of things you just need to set up first. One is, what sort of plot do you want? Plot type, you've got azimuth, which is a bird's eye view, elevation, which is a side view, which to me is perfect. You can see what angle the radiation is, and there's 3D. But having chosen elevation, it then wants to know something called azimuth angle, which is basically what slice are you actually looking sideways at. And I would suggest 0 degrees, which is where the antenna is. And once you've set that, forget it, it's all set, do your plot, and there it is. Which doesn't look too bad. Maximum here is what, 28 degrees. There's a little bit of front to back ratio, but well, probably about 1 S point. It's hardly worth worrying about. What I don't like is all this radiation that's going vertically upwards, because in my book, that's a complete waste. I'd sooner that be going where I want it. But if you're happy with this, then it would work. It would be a bit of a jack of all trades, but it would work. And if you're happy with 7.1 meters, but I wanted better than this. I wanted something compact, and I wanted it shrunk. And how do you shrink antennas? Well, there's 2 things that come to mind immediately. Number 1, either use a loading coil, or number 2, use a capacity hat. Well, I don't know about you, but trying to put a capacity hat into a closed loop was a little bit beyond my tiny brain, so I ignored it completely, rightly or wrongly, and thought, I'm just going to concentrate on loading coils. And that, of course, raises 2 questions. Where to put it, and what value? Well, the where, I think it's quite easy to reason, because if you think about it, coils are all about inductance, which is all about magnetic fields in them, which need a current to produce it. So basically, it's all about current. So it stood to reason to me that the best place to put a coil for maximum effect is where the current is a maximum. And for these HF 1 wavelength loops, there's 2 places. One is the feed point, and the other is diametrically opposite. And we can see that if you look at this view, then at the feed point, the current's high, because the red line is the current, and halfway up Y2, again, the current is at a maximum. I tried the feed point, and I really wasn't very happy with what it did. So again, I aborted that and concentrated on just putting it halfway along Y2. The only thing left then is what value? Well, your guess is as good as mine, frankly. I guessed that it was going to be microhenries, because inductive reactance is what? Do you remember? 2 pi FL. So I thought, well, if F is in megahertz, why not make L microhenries? Then the mega and the micro will sort of cancel each other out. That seemed a good starting point. And as regards how many microhenries, well, it was one of those, and I just chose 50. So to do that, I would click on the loads, which I've already done, and if I put that here, you'll see that if I click on loads, then there it is, and you'll see that I've chosen Y2, 50% from end 1. The L is 50 microhenries. The resistance is 1 ohm, which I thought would be more than adequate, and of course no capacitance. And you'll see in the diagram that there's a little red, very hard to see it, there's a little red square in the middle of Y2, just showing you where the load is. So now all we've got to do is find out whether this coil has done what it's meant to do, which is lower the resonant frequency. We do that by, again, doing an SWR plot, only this time I've started it at 5 megs, because I've no idea, A, whether it's going to work, and B, how much it's going to shift it by. Well, there is a resonance, and if I click on it, well, it says underneath it's 8.5 megs. So really, I would say job done. Remember, the antenna is still the same 7 meters per side. And previously, without the coil, it was resonant at 14.4. Now with the coil, it's 8.5. So to get it back resonant at 14.2, I've got to shrink this. And I've got to shrink it by roughly 8.5 as a ratio to where I want it, 14.2, which is about 0.6. Now I struggled to find a nice easy way to do that, and the only way I could actually find was that if you go into the wires window and click on the wire tab, it's the only one you need, and click on group modify, immediately it selects the first and last wire for you and click OK. They're all now blued out, which basically all that's doing is it's saying, right, whatever you do to one wire will happen to all 3 equally, which is what you want. We can now go back into the wire tab, but this time we click on change loop size. And we're going to change the circumference, and we're going to multiply it by 0.6. If I click OK, you'll see the size shrink immediately, and bingo. So job done. But unfortunately, not quite as simple as that. I haven't found a way of getting around this. If anybody knows, please let me know, put me out of my misery. But you'll see that not only has it shrunk, but it's shrunk away from the ground. Because if you look at you can just about see it, Z for Y1 is no longer 1, it's 1.8 odd meters. So we need to drop it back to 1 meter above ground. No way, no problem. Go back into wire, change height by, type in here minus 0.8, whatever it is, click OK, job done, and we'll see that if I just get rid of that and open what I've done, and it's now, we can do an SWR plot just to prove the point. The antenna is now shrunk, it's 1 meter above ground, and the resonance now is somewhere between 14.2, 14.3. You could tweak that if you wanted. And it's under 2 to 1. Only just, but it is. What about the plot? Far field plot. Well, I was right chuffed when I saw this, because immediately it's still 28 degrees maximum, but I've lost all of that which was going vertically upwards. It's all now being, hopefully, compressed into the lower lobe. And you could say, job done. It's virtually omnidirectional. It's under 2 to 1. It's resonant around 14 megs. Height, hard to see, but it's actually just under about 4.5 meters high, the overall height now. And if you can live with just under 2 to 1, that's it, done. But I thought, well, the 50 microhenries was that, wasn't it? Wonder what happens if you tweak the 50 microhenries. Well, I did that, tried various other values, and I ended up, as you can see, with a value of 20 microhenries. Still, I've kept the 1 ohm. Of course, now that we're not loading it so much, instead of 50, it's only 20, it needs to be made a bit bigger. So I've done that. That, of course, changes the height above ground, and I've done that. And it's now hopefully resonant at around about 14.2, and eventually bingo. And it's resonant now between 1422 and 1424, and as near as damn it, it's 1 to 1. Has that messed up the plot? No. It's actually 27 degrees. It's pretty omnidirectional, and I would say job done. The height now, best thing probably now is I would just go back to the PowerPoint and we'll just show the summary. We can see that it's now, instead of 7.1 meters high, it's only 5 meters high. The width has dropped from 7 to 4.63. Yeah, it's resonant where I want it. Good SWR and a low enough radiation. Job done. So I decided to build a prototype, bit of a lash up. But the first thing I had to do, of course, was to actually wind a 20 microhenry coil. Well, I sort of used MMANA. I mean, there's plenty of these things on the web, but MMANA has got this built in. I chose, looking for number of turns, put the 20 microhenries in. I used some 4 centimeter diameter acrylic tube I bought for under a tenner off Amazon. I bought a reel of 0.9 millimeter enamel copper wire, again off Amazon. Wound it. Don't look too closely at the winding because I'm no expert when it comes to winding. And it was about 22 turns, which is what I did. I measured it on a cheap and cheerful LC meter and it came up with about 22 microhenries. So I thought, right, give it a go. This is it. Rather crammed into my back garden. And don't look too closely at the insert because you can see how poor I am at winding coils. But hey, it worked. All I'll say is that to try and work westerly into the States from my QTH is difficult because the land just rises in that direction. It's not a favoured direction by any means. All I can say is with this antenna and okay 100 watts, I've actually worked and got 5 and 7 from New York, which I was quite chuffed at. And equally, I've had reports from Finland and around the place. So as far as I'm concerned, it does appear that theory has been, proven in practice. Whether it's going to be proven in practice in a demo, I'm just going to give it a quick try. If I can actually hear somebody, then, that'll be possible. We'll see whether we can actually just get a quick report and then we'll open it up to any questions. Goes out. Golf 4 Charlie, Hotel Delta, portable demonstration station. Appreciate a report, please. No. Well, it's a good signal, and the SWR is about, according to me, about 1.2, something like that. So it's getting out. You can pick up stuff. I mean, whether I need to work in I mean, we can try and make a report, but who cares? I mean, it works. It's picking stations up. I haven't really been able to test it over any real period of time. But suffice to say, it works. I got a lot of satisfaction out of the design process and actually seeing it sort of work in practice. All I'll say is that, if anybody here is sufficiently well, motivated to give it a go, I'm more than happy to give all the help I can. If you want any copies of the Easy NEC files, I'm more than happy to pass them on. But I've enjoyed the process. I just hope that you've enjoyed the talk, found it interesting and not too boring, shall we say. So I'll just open it up to sort of any questions. I'm no expert, I hasten to add, but if you've got any questions, I'll do my best.
Did you think about current feeding it from the bottom with a, say, put a tallway ground it and then try?
I didn't get that far, to be honest. I sort of thought, in fact, I have fed it with just a normal, without a ballon. I mean, at the moment, it's a one-to-one ballon I've got at the corner. I have used just a centerpiece, a dipole centerpiece with a 259 connector, and that seems to work. So I thought, well, it works, you know, why not?
Something like a mag loop where you actually use a tallway to actually, you know, effectively induce the field into the...
Yeah, I mean, you don't need to, because with a mag loop, you've got such a ridiculously small radiation resistance that the problem then is actually trying to couple that in, whereas here, you've got, well, to all intents and purposes, 50 ohms to feed into, and virtually purely resistive with the one-to-one. I mean, it appears to work. It's given me roughly anything from a 1-to-1 to about a 1-to-3, 1.4. Whether it's here or in my garden, where there's probably a tree nearby. There's a aluminium greenhouse just at the back, etc., etc. But yeah, I mean, for 5 meters high, it's not particularly, you know, obtrusive.
Would it be worth trying a counterpoise underneath it, you know, a surface ground and improving your ground?
That wouldn't help really, because all that would do would just improve the vertical, really you're really using the vertical polarization from the sloping bits, and that's giving you the low angle. And the beauty is, I mean, yeah, you could say to me, well, why don't you just use a 5 meter vertical? That's a quarter wave. But yeah, you'd need a good ground plane. We'd need lots of radials, etc. And that's something I wanted to avoid. Whereas this, I mean, it just concertinas up, throw it in the back of the car, and it doesn't take a great deal to actually put it up. You might be asking, or thinking to yourself, what would have happened if I'd used an aluminium pole? I did do an easy NEC analysis of that, and yeah, it works, and it's the same sort of radiation pattern. The SWR was just a bit higher. It was about 1.5, 1.7 to 1, and I did try changing the inductance, and it was somewhere between 10 microhenries and 20 microhenries. But I've built one of those, and I bought one of these aluminium tripods with extending up to 7 meters, so you don't need the top bit, so it's nice and stiff, and I've used that, and that works just as well. So it's quite adaptable, but hopefully, you know, you found it interesting, and whether you want to give it a go. But I've enjoyed it, but then I am a bit of a nerd when it comes to this, so apologies for that. Okay.
What was your soil type then, Terry?
Well, I just went for middle of the road. In reality, I know that if you go down about, probably about, I would say, 3/4 of a metre, you get to clay, and then you just get to shale, because I'm on the top of Cornborough Road. Because I know I tried to dig a fish pond, and I didn't get more than about 2 foot deep before I got stuck. So it's not the best of grounds. Whereas, I mean, this is be interesting to see what you could actually work out here, because you know you've got quite a decent soil underneath. But at the moment, it's just self-supporting, and with using one of the garden umbrella stands, stuffed it into there, and it's one of these cheap and cheerful extending fiberglass, like fishing rod type pole things, which are quite cheap. I mean, the whole thing can be built relatively simply. I mean, a couple of insulators, a feed point, a pole, and wind the coil, and job done. You know, doesn't take long.
Are there any commercial manufactured ones?
Not that I'm aware of. I mean, I'm sort of tempted to actually publish it as an article in some magazine, but I'm not. I mean, I wouldn't be surprised if it's been done previously. I've not come across it in all the Googling I've done. I've seen coils used in delta loops, but not with this particular configuration. And it works. I mean, the one thing I did try is seeing what happens if you put a vertical behind it to act as a reflector, and and that was quite interesting. You can then get sort of a good front to back ratio by positioning the position behind the feed point, and also adjusting the height of the actual vertical, really. But I'm pleased. I mean, I wish I had enough space to be actually able to actually leave it up permanently, but I'm afraid the XYL would want the lawn to be used to better things, I'm afraid. But it's suffice to say it works, and it can be thrown in the back of the car. It'd be nice to go out to something like probably the Burrows sometime and just see what it really can do. But the only times I've been able to test it has been during the day when conditions haven't really been at its best. It'd be better off, you know, perhaps evening time when probably the delay's disappearing and you get sort of better propagation.
What you've achieved is by using a recognised program, you've put in your requirements of the height, how far off the ground, what your subsoil is, and you've actually achieved your ideal figures from designing what you want, rather than the usual way of measuring out the wire.
Yeah. I mean, I did think that it would make a useful commercial product if you were to perhaps get a base which was attached to a pole, an extending pole, and you had two, say, telescopic like antennas, which just hinged and dropped. Yeah. And attached to the ends of those was the wire that went up to the top, and you fed it at one end and just adjusted the sliders if you needed to just get the right resonance, etc. That would be another possible way of doing it, and it would be quite compact then. But no, I mean, basically all these programs will just simulate what you put in, and all I've done is start with a standard delta and just think, well, common sense to me was put a loading coil in. There are ways of adding capacitance apparently to loops, but it's messy and not terribly practical. So I just stuck a coil in and away you go. I did try changing the position of the coil and the position of the feeder, and you can get some sort of front to back ratio, but then it's at the expense of a bit more radiation going upwards. It sort of goes in this way and it squeezes it up that way rather than perhaps all being kept into a low angle. So this I thought was, you know, a good compromise. As I say, I've worked well, probably around from sort of like North Finland, Austria, as far as sort of Israel. I was actually listening to a station in Malawi coming in about 5 and 8, which I'd have loved to have worked, but he was in a really good heart-to-heart rag chew with somebody back home. But, you know, picked it up, so I was sort of quite pleased with it. So So I hope you haven't been bored, that's the main thing, and enjoyed it. And
thank you very much to Terry, our president, G4CHD, for a lovely talk. I hope you enjoyed it, found some useful information. Next month will be a quiz night, and then the following month, Mark is at the back, I think it's G6BNB, is it? He's going to give us a very interesting talk about the special effects in the movie industry. And I know what that's like because my ex-father-in-law used to be in the movie industry themselves. So that will be a very interesting talk. Thank you very much, everybody. I've been watching online, see if anybody wanted to make any comments, but they haven't. I was going to pipe up with any comments, but there you go. Thank you very much, and we'll see you next time.